Number 7 part A. One of the results of alpha particle scattering experiment is that a very small minority of the alpha particles are scattered through angles greater than 90 degree. State what may be inferred about the structure of the atom from this result. So we need to determine, we need to state the structure of the atom. So let's suppose for an atom, as the alpha particles pass through, most of the alpha particle remains undeviated, and some of the alpha particles are deflected. And most of the alpha particles are deflected through an angle of 90 degree. So why only small amount of alpha particles are deflected through an angle of 90 degree, or alpha particles are scattered through angles greater than 90 degree or greater than 90 degree? So why small amount of alpha particles are deflected greater than 90 degree? Because for the nucleus, so the nucleus is very small compared to an atom, and the nucleus is charged. So because as alpha particles are deflected, so first of all, as alpha particles are deflected, and why alpha particles are deflected? Because alpha particles are 2, so alpha particles contains 2 protons. So 2 protons, that means alpha particles have a charge of +2. Since alpha particles have a charge of +2, and nucleus also contains protons plus neutrons, so nucleus is obviously charged, that is positively charged. So since these two positive charges interact, so obviously the alpha particles are deflected, since alpha particle has small charge compared to the nucleus. Therefore, the nucleus is charged and therefore deflection occurs. So now we have stated that deflection occurs. Now why small amount of alpha particles are deflected through 90 degree? Because our nucleus is too small, and so most of the alpha particles pass straight through without any deviation, and only some of the or very little amount of or nucleus is very small compared to the atom. So most of the alpha particles pass straight through without any deviation, and only small amount of alpha particles are deflected through angle greater than 90 degree when they pass close to the nucleus. So when the alpha particles pass close to the nucleus, they are deflected through angle greater than 90 degree, and the rest of the particles pass straight through without any deviation, since the nucleus is very small. So the nucleus is very small, therefore only small amount of alpha particles are deflected through angle greater than 90 degree, and the nucleus is charged, therefore deflection occurs. So nucleus is charged, therefore deflection occurs, and since the nucleus is small, so less deflection occurs. For part B, a hadron has an overall charge of +E or +E. So the hadron, for the overall charge is +E. The hadron contains 3 quarks. One quark is a strange quark. State the charge in terms of E of the strange quark. So for up, top, and charm, the charge is +2/3e. So for up, top, charm, the charge is +2/3e, and for down, strange, and bottom, the charge is -1/3. So for strange, the charge is -1/3. The other two quarks in the hadron have the same charge as each other. So other two quarks have the same charge. That means if the charge on a quark is x, then the other would also be x, since they have same charge. So by considering the charge, determine a possible type flavor of the other two quarks, explain your answer. So we consider, since the other two quarks have the same charge, so we consider as one charge as q, then the other charge would also be q. So q, since there is 3 quark, so for one quark, the charge is q, and for the other quark, the charge is q, because they have the same charge. And here we have given that the strange quark, so strange charge has a charge of -1/3e. And for the hadron, the overall charge is positive e, or we can say that 1e. So it is positive e. So 2q is equal to positive e, that means 1e. And if we move 1/3 to the other side, then it would be +1/3e, 1/3e. So what is the overall charge that we get? It is 4/3e. That is for 2 quark, and for 1 quark it is 4/3/2, that is 2/3e. So 2/3e for 1 quark. So for 1 quark the charge is 2/3e. So 2 by 3, so 2 by 3 can be up, top, charm. So it can be up quark or a top quark or a charm quark. So what is the possible flavor of the other two quark? So it can be up quark, that is you can write just up quark or just top quark or just charm quark. That is any of the from any of the three you can write any one value. That is either up quark or top quark or charm quark, as all the three have a charge of plus 2 by 3e. That is plus 2 by 3e plus 2 by 3.